Hello, this is Keith Larson, editor of Control Magazine and ControlGlobal.com. Welcome to this Solution Spotlight episode of the Control Amplified podcast. With me today is Joe Incntri, Director of Marketing for the Americas with Krohne, a world-leading manufacturer and supplier of solutions in industrial process instrumentation. We're here today to talk about the ongoing evolution of ever smarter instruments and how their onboard intelligence and communications capabilities are making industry safer, more reliable, and more efficient. Welcome, Joe. A real pleasure to have you with me today.
Thank you. Glad to be here.
Well, I guess we could just jump right into the deep end here, not to date us too severely, but you and I first met back in the day when any sort of smart process instrument was more vision than reality. It seems back then most instruments' communication capability started and stopped at a single process variable configured to vary over 4 to 20 milliamp loop. Back in then, did you have any sense of the new instrument capabilities from both communications and intelligence perspectives that we would emerge and that we'd be talking about today?
Well, I think you might be forgetting something. Remember those infamous 3 to 15 psi pneumatic loop signals that were around back then as well?
That goes even further back, but I think we still have some of those for the random control valve out there.
Exactly right. Well, back then, when we first met, I was primarily involved with a company that was dealing in the oil and gas and chemical industry markets. And as you know, given your title there at Control Magazine, those folks have to deal with some pretty gnarly safety situations. And there's a lot of emphasis on process efficiency. Mm-hmm. And I think as a result, they really developed some sophisticated control strategies that needed more than just the analog output coming out of the instruments. So the sensor networks had to evolve beyond the analog world because of that need for more information from the point of measurement. Now, since then, the pioneering work that was done for some of those markets, including the power industry, has become more commercialized and standardized throughout the industry. And as a result, we now see some of those smart features available to everyone. I think it doesn't hurt that the microprocessors and storage technologies that developed as a result of our insatiable need for smart consumer devices also played a part. And as a result, I'm guessing at this point, it probably costs more to produce a dumb device than it would to make a smart one.
Probably, yeah.
Yeah. Now, on the other hand, it kind of makes me chuckle in this day and age to think that some of the devices that are responsible for safe shutdowns in some of the most critical processes, like perhaps a nuclear power plant's reactor chamber, are still amongst the dumbest mechanical-only devices. But let's face it, they're still some of the most sophisticated in terms of reliability.
And probably some of the most expensive to develop and get certified for the service that they're in. Yeah,
exactly right.
What end user value propositions are these smarter instruments able to accomplish or deliver today compared to back in the day? Can you share some specific examples of innovations and how they're benefiting users?
Well, as you mentioned at the outset, Krohne is a process measurement instrumentation company. So our focus, our core mission is the measurement itself and to make it as reliable, repeatable, and as traceably accurate as possible. Because we're a measurement instrument company, we also need to make sure that our devices' outputs are accessible to the people who need them, which are the system users, who need them for either process control, monitoring, or custody transfer purposes. Now, each of those measurement use cases has its own set of needs. If we look, for example, at the process control applications, we can take a peek at the Coriolis mass flow meter line, the OptiMass, which now incorporates most of the popular digital buses, but we have also added recently a Bluetooth as a secondary channel. Now, this feature allows an operator or technician to set up the instruments at startup to monitor its performance during operation, and even if necessary to do a verification using the instrument's internal diagnostics at any point in time. Now, this can greatly help in extending maintenance cycles. Of course, you can also use that feature should there be any alarms that need to be dealt with. Now, while much of that can be done remotely via the digital bus, the convenience of being able to do that in the field adds a lot of value for the instrument technicians in the plant without really having an impact on the process operations, or a negative impact on the process operations.
And with Bluetooth, I'm sure you can go into intrinsically safe operations as well, and you don't have to worry about declassifying the environment to attach a handheld or something like that.
Or for our friends in Canada, if they need to access an instrument from the comfort of their pickup truck, they can do that as well.
Yes, absolutely. Or in Texas, as the case may be in last year.
Exactly right, lately anyway. Now, if we look at custody transfer applications instead of the process control ones, that's where ultimate accuracy and repeatability are of prime importance, since the meters basically are acting like dynamic cash registers. The built-in diagnostics in, for example, our ultrasonic flow meters provides a continuous stream of supplementary data that can be useful when you have to settle some contract disputes, for example, for custody transfer. The additional data elements can provide clarity about what happened during the dynamic flowing conditions at any point in time. For example, was there a flow profile disturbance, a change in pressure or temperature, or even a fluid change? These smart meters for liquid or gas flows now can tell you with outstanding resolution or accuracy what's going on in the process. We shouldn't also forget level instruments. Along with the better resolution and the more tightly focused beams that come with the higher radar frequencies that we now provide, the latest instruments, both for radar and guided wave radar, or TDR, also feature advanced signal processing and diagnostics that can now help you successfully fine-tune an application that could never even be considered before using one of these technologies. And the maintenance and service are also greatly simplified based on the wide amount of available information from the instruments for the technicians on the site. And I could go on and talk about smart pressure and temperature devices and even analysis or analytical devices. But I think we've talked about enough examples for the moment. The advances just keep on coming.
Yeah. I think it's really interesting because the early stuff seemed to really focused on self-diagnostics of the instruments. Hey, how am I doing? How am I working? But more of the advances lately are embedding on the instrument diagnostics for the process itself, not just the instrument. Can you talk a little bit about what you've seen in that area?
Sure. Yeah, you're absolutely right. I mean, there is more information available, and clever people are trying to find different ways of making use of it. And you might remember back at the turn of the century, seems like such a long time ago, doesn't it? Yeah. Krohne might have at the time introduced really something that was revolutionary. It was the newest iteration of its venerable mag meter line. They call it the OptiFlux, and it was one of the first mag meters on the market at the time with a huge new suite of built-in diagnostics that did what you were talking about. Yeah. The moniker they came up with at the time was 3 times 100% diagnostics. Kind of rolls off the tongue, doesn't it? At the time, it was kind of revolutionary because it monitored the sensor and the electronics, or the signal converter, but it also reached into the process to identify some issues, for example, like a less than full pipe, or maybe somebody might have left the valve less than fully open, so that would cause a change in the flow profile. Mm-hmm. And it was a pretty big deal back then, and it was a direct reflection of the available new processing power that was being integrated into the flow instruments at the time. And since then, the pace of development has kept going and has skyrocketed lately with the advent of cheap memory on top of the processor speed. So now more data is available for things like heuristics to help diagnose unusual and unexpected conditions at the sensor faster than ever, or even combining sensors. One example of this additional processing is our entrained gas management feature that's found on all the range of the OptiMass Coriolis meters I mentioned before. This entrained gas management feature is always on and immediately identifies two-phase flow conditions and keeps on working without losing measurement, no matter how much of gas is in a liquid line or how much liquid is in the gas line. Now, to do that, there's an incredible amount of data that's being generated in these two-phase flow conditions, but the pickup coils and the processor is able to still pick out the actual signal from all that surrounding noise that's being generated by the entrained gas. For us mere humans who can't seem to keep up with the advances in the instruments, they're also equipped with better tools to help us interpret what's going on, like the aforementioned Bluetooth feature, which is also accompanied by a smartphone app, of course, for convenience. And as mentioned before, for process applications, the primary role of the instrument, as far as we're concerned, is the prime measurement itself. But I can foresee a day when this pace ends up in a seemingly infinite network bandwidth, which combined with ever more powerful onboard processing will ultimately result in all of this diagnostic data feeding into a dedicated plant system that might be strictly for the analysis of the diagnostic or secondary information from many devices in the field in order to start evaluating patterns of behavior in the process for even safer or optimized operations. That's kind of like what's happening right now in computer networks as we speak. They're getting really, really smart and taking advantage of all that data that's being generated.
Oh, that makes a lot of sense. It seems that we may already have more data than we can handle in some cases, because you look even back to the original HARP protocol, capable of sharing a lot of useful information with control or some parallel asset management system like you were alluding to. But many plants still use HARP only for commissioning or ad hoc interventions via old handheld. With the advent of digitally configured I/O systems and increasingly digital field bus systems, do you see an increased adoption of more integrated instrument communications for new projects?
Yeah, I think so. I will say that the HART, the old point-to-point HART communications, I think, has already achieved basically its peak value, and I don't see that people will invest a lot more in developing that further. I may be wrong, but that's kind of my perspective on it. But on the digital bus front, I hate to be negative, but sometimes what we call standardized communications are not so standardized due to conflicting priorities, shall we say, amongst vendors and users.
Yeah, standards are great. We got lots of them. Yeah, exactly.
That's exactly right. So sometimes what happens is what should be plug and play sometimes ends up being plug and pray. Especially when it comes to the exchange of secondary variables that the instruments can provide. As an instrument manufacturer, independent as we are, we're sometimes caught off guard by changes that a system vendor might impose with the advent of newly released network solutions that they're busy creating for their markets. Sure. Now, we try to do a pretty good job of staying current, but you have to realize there's a natural product development lag that comes into play. So that's something we have to deal with. But, we have most of what we need for process plant applications. We're not blind to the fact that we do see a desire from users to get as much information as possible. But they have to realize there's an economic trade-off they must consider, since there often needs to be additional investments in hardware or software at their end. Now, the other point that must be said from our perspective, because we see it all the time, is that while we're generating a lot of advanced features and secondary variables that can be available, we still find that few end users actually take full advantage of what they can provide and have those features implemented in their operations. Since, after all, their primary focus is on running their plants, and that's their primary objective, and sometimes they overlook the additional benefits that are provided by the additional data that is available from the instruments. Now, on the other hand, in custody transfer applications, the diagnostics have now become a very common and important part of the criteria that customers use to evaluate their instrument vendor selection, because, again, the measurement is core, and anything that impacts that measurement, they need to know about it as soon as possible.
Yeah, that could be money slipping through their fingers, or product giveaway if they're not careful. That makes sense.
Exactly right.
What about, just to change the subject a little bit, what implications does the rise of the whole industrial Internet of Things and new architecture models such as NMR's kind of parallel path, I think you alluded to that before, for secondary information, what are the implications for these local or cloud-based applications have on the smart instrument landscape?
Well, it's interesting you bring that up. I mean, Krohne believes that this is a foundational requirement, and we are a German company, and NMR is a German consortium, or at least has started there.
Yeah.
So we've actively participated in that model development, if I can call it that, and that automation pyramid, as they refer to it, basically allows suppliers to focus on their areas of specialty. So for us, we can focus on the measurement while providing that secondary channel. And it provides a model for the safe interconnectivity to the process control systems. Now, all of the secondary information is channeled on this separate parallel path, as you say. And while the data that is most important to the safe operation or plant is channeled through the main channel, the second channel also, because there's a lot of valuable information there, can also add a degree of security, for example, alarm management. Mm-hmm. I've got to say I'm no expert in this realm, but I know our team and our Krohne's team in Germany is an active member and is actively working as part of the open architecture consortium of vendors that makes up Namur, not just vendors, but users as well, to make sure we stay at the forefront of those developments.
Mm-hmm. Yeah, that makes sense. As instruments continue to get smarter and their communications faster, what other new developments do you maybe foresee in the future?
Well, that's a good question.
I won't hold you to them, but yeah.
Yeah. Well, let me just say that for me personally, at my age, as you alluded to earlier, I'm on a quest to continue to get older and dumber, at least as far as this topic goes, because these developments will far outpace my ability to keep up. I'll keep on remembering the good old days when life was simpler. Sure. But seriously, one challenge we already know that needs to keep up with all of the exchange of information is that of security. Just a few weeks ago, we heard of hackers' infiltration into that water treatment plant's operations in the news. And I fear that the more dependence we have on the digital realm, the more there will be clever folks who have, let's say, a perverse motivation to see if they can break in. You know, back in our days of analog or pneumatic signals, as we talked about earlier, perhaps a high perimeter fence or a security guard at the plant gate might be sufficient to keep the bad guys out. But now you've got to worry about every laptop and an internet cafe somewhere in the world as well. Yeah, so I can foresee that instruments, smart instruments, will not only be able to continue to discern the problems with either their own behavior or the process itself, but they might also extend to being able to spot unauthorized access as well. Here's hoping, anyway.
Yeah, absolutely. Well, that makes sense. Well, thanks, Joe. I think we're about at the end of our time. I really appreciate you taking the time to share your insights with us today, and a real pleasure, as always, to speak with you. For those of you listening, thank you for tuning in. And again, this is Keith Larson, and you've been listening to a Control Amplified podcast. Thanks again. This is Joe Incntri with Krohne, and thanks for joining us. And if you've enjoyed this episode, you can subscribe at the iTunes Store or at Google Podcasts. Plus, you can find the full archive of past episodes at controlglobal.com. Signing off until next time. Thanks again, Joe. Really appreciate it.
Thank you. Thanks for having me.